Okay, so the clock face, the 12-hour clock face that we're so used to, seemingly innocent, has no meaning, has no hidden connections to what the Hermetic tradition or the esoteric, some will call it the occult. Occult means hidden, it does not mean satanic, just to put that in perspective. Now, begin with a construction line, and well, actually the clock has quite a bit of meaning, has quite a bit of connections, and especially through what will be termed sacred geometry. And so I'm going to start with this line, draw a circle, put the compass point on the edge of the first circle, and now we have what's called the vesica piscis, or the vesica piscis, the vessel of the fish. Now we'll do the same on the underneath. Now we'll have what will be termed a double vesica piscis, 3 circles. Now where these meet, so this here, here and here, so we already have 3 circles. Now we're going to do 7, 2, the 4th, the 5th. I'm just rushing, so it's best to be as accurate as you can. Take your time, get your point and I'm using a thicker point. You want to use as fine a point as you can. But now we have what's termed the seed of life. But what we really have most important is the hexagon, as in beehives to begin with. And it's just again, it's such a lovely piece of geometry that these 6 circles around the outside will perfectly divide up the inside circle into 6 pieces. Now, this in itself, as long as you set the compass to the right length, for instance, the metre, will also give you the Royal Egyptian Cubit. So much information actually emerges from that. But I'm going to join these together again, just a pointer when you're drawing. If you put your point on, and then you can line your ruler up rather than try and line the ruler and then get the point on there. And if we follow these around, we have a hexagon, a perfect, a 6-sided polygon. Euclidean geometry, beautiful stuff. It's a shame that it's sort of not taught properly in school. It is taught properly in school, let's be fair, but it's not taught in a way. It's basically made to be as boring and as bland, as uninspiring as you can make it, yet it's actually quite wonderful. There's a lot of information in there, and as we'll see, it connects to time and the clock. And we can say, okay, so now we have our hexagon, a 6-sided polygon. Now I've begun this construction with a vertical construction line. As you can see, it cuts through these petals perfectly, and so if I was to repeat that and go through, what we would divide this construction up into 6, again, hexagon, 6. And so now we have those around there, but just to focus on, so I'm going to show you how to construct or to draw a clock. And to begin with, so we have this angle here, and that angle, okay, because we know, okay, so let's highlight that a little bit more. So what we have is a series of 6 equilateral triangles around here. 1, 2, 3, 4, 5, 6. 6 equilateral triangles. This is an act, it's accepted. It's Euclidean geometry. We sort of know that for sure. But now if we look at, okay, so because we know it's an equilateral triangle, we know that this angle is 60 degrees, and therefore this angle is 60 degrees, therefore that angle is 120. 120 minus 3, 60 degrees. What we have is 240 degrees. Now you could work off 240, but what we now have is 6 of these around the outside. So the angle which defines the outside of the hexagon is 240 degrees times 6, which equals 1,440 degrees. Now, how does that connect to the clock? Well, there are 1,440 440 minutes per day. That's a nice, now 1440 degrees. Now each degree can be divided into minutes and then seconds. So 1440 degrees, each degree is of 60 seconds. So 1440 degrees times 60 means that the outside angle of the hexagon, 1440 degrees, is 86,400 minutes of the compass, and there are 86,400 seconds per day. So that's a nice little start-off point to begin to connect the geometry with time, and these things also connect through measurement. Time is essentially a measurement. Geometry is one of the, basically the core element of the quadrivium: arithmetic, geometry, astronomy, and music. Now, even there's lots of musical aspects and proportions built into this geometry. But so as a start off, that this hexagon, whether it's a beehive, you'll see the hexagon appear so many other places in nature. Nature demands that you do these things. This is not arbitrary. It's just this beautiful harmony of the circles. This is the most efficient use. The hexagon is stackable, and that it interlocks, and so that each, just like a beehive, the hexagon fits together. But now we already have those numbers established, so we know that there's a lovely link between the numbers in the degrees and minutes of the hexagon is also a connection to the minutes and seconds of the day on the 24-hour clock, where you're using a 12-hour clock face. But using that same construction, so let's say you've got an old, you can literally draw a clock. And this will also have astronomical implications, especially with precession. But if you're into astrology, it's also a lovely way to create a zodiac. And in astronomy, it's called precession. Astrology, it's however you want to look at it, it's got pretty much the same thing going on in there. So again, we're drawing the seed of life. We're creating a hexagon. I'm drawing it in a particular way, but as long as you start with a circle on the inside, you work your way around, and the circle will be divided up beautifully into 6 sections. Now, with our compass on the center point, we're going to draw a clock, but it's also a zodiac. So whether you're into precession or whether you're into astrology, this division of 12 as in the 12-hour day, or the 12 months of the year, the 12 signs of the zodiac, or the 12 ages of precession. And here already what we have is all the necessary elements to create a clock. And so what I'm going to do is first begin by going through the petals at the center of that, the seed of life. And so now we've divided this larger circle into 6 sections. And with those, I'll draw what most people would consider the Star of David, famous, most recognizable from the Israeli flag. But you could go back to places such as the Osirion. This geometry is very, very ancient. It was well before that period. The menorah was actually the original symbol of Judaism. But that's neither here nor there, because this geometry is universal. Actually, this geometry is actually the flag that the NASA or the UN has used as the Earth flag, which I think is very cheeky, because this is cosmic geometry. It literally is universal. So for Earth to try and put it so if we were to go to the interplanetary organization, it would be very, very presumptuous of us to use this flag. It would be like, I don't know, like using this a picture of a star as our flag, and sort of everyone will probably be using it. So, okay, what we already see is one equilateral triangle. So, and if I repeat that and do it upside down again, so it's just two interlocking equilateral triangles, and I have the Star of David. Now it's necessary to draw this because, well, actually I should repeat that. It's not necessary to draw this, but I'm drawing it anyway. It will become important later, but we'll change the color of the texture. Now, we already had our 6 points going through here, but with this seed of life, you'll also notice 1, 2, 3, 4, 5, and 6. So what by drawing the seed of life in this way, we've already actually divided the circle into 12 equal units. So what you really already have is your template for a clock or for a zodiac, in whichever way you want to think of it. And so what we've already done is to divide this circle up into 12 equal points. And so 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we already have our template for the clock. We also have the 12 ages of precession, or the 12 signs of the zodiac. And what's also worth noting is, because we've divided a 360 degree circle, so 360 degrees over 12 equals 30 degrees. So each one of these wedges is 30 degrees, which is so important in the pendulum. But it's also worth noting that the Great Pyramid is 30 degrees north of the equator. Now, technically it's 29.99 or something like that, but Heliopolis is exactly 30 degrees north of the equator. But because of the way the atmosphere works and a whole bunch of technical stuff, the Great Pyramid could also, especially if you're standing on top of it, would put you at 30 degrees north of the equator. But the Great Pyramid, or the 3 Great Pyramids of Giza, are actually aligned to Heliopolis, and Heliopolis is, if you were to use a GPS, is at exactly 30 degrees north. Now, if you were to draw that line across this 30 degree angle using the Great Pyramid, and imagine this as the Earth, this passes through Easter Island, Angkor Wat, Petra, and so many other important sites. Now, there have been a few who have pointed out that. Now, if you were to view that from the top, from the North Pole, you'd actually also find that the relationship of distance between them is related to the golden mean phi, 1.6180333988, etc., etc. And so there is this lovely golden ratio connected to there. Now, it's probably a bit messed up. Okay, so now, for instance, let's draw. So you're going to skip every of these green lines, or the odd number. Let's think of it, the odd numbers. We're going to skip every odd number and join the next. And so we go from 5 to 9, and then 5 to 1, and then 1 to 9, and what we have now is another equilateral triangle. Essentially, we're going to create a Star of David offset by one portion of this circle. And now from 7 to 11, and 7 to 11, that's actually a Great Pyramid ratio as well. And 7 to 3, which is cool in itself because of a 14:11 ratio. But again, it's just so wonderful that these things all blend together. I think it's a superior system of learning because with a small amount of info. But okay, we in green now, we have another Star of David tilted. Now because of that, okay, so I'll just highlight this one just to show what I mean. So what we've done is now we've bisected that angle, so we can, from the center, we can run through that point, and we can also do the same over here. And we already have a 30-degree angle. What I've done now is create another 30-degree angle, and if I was to repeat this pattern, what we've done is now divided each of these 12 sections into two. So we would create 24, so as in 24 hours a day. But this 30 degrees is so important because it connects to the pendulum. And so if you draw it like this, we have the pendulum. Now if I was to make, out of, beautiful coincidence, let's call it, if I was to draw this so that this was 1 meter long, this section would be 5.236 radian, or 1.5236 meters. So a 1 second pendulum, 1 meter defines the second. You've probably heard, that it was the French dividing up the Earth into 40 billion sections. Well, that actually came much later. The meter was actually begun as a pendulum. Marin Mersenne, centuries before the French. It's again not contested. It's just not taught, unfortunately. So 1 Egyptian Royal Cubit is that section of arc. 1 meter is 1 second, and there are, as we saw earlier, 86,400 seconds per day. The Great Pyramid is defined by this Royal Cubit. The Great Pyramid is also 30 degrees north, coincidentally. And again, and now if I was to stand at the corner of the Great Pyramid on the northeast corner, what I have is the maximum visible base. You can only ever see 2 sides of a pyramid from ground level, and we also have the height. Now if I multiply the height of a pyramid, including the paving stones, so the socle, times 86,400 as in seconds per day, what I get is the polar diameter of the Earth. If I multiply the maximum visible base, or double base, including the sockets at the corner, multiply max visible base times 86,400, what I get is the equatorial circumference of the Earth. And so time, the meter, the Royal Cubit, as in 86,400 seconds per day, the hexagon, again, the 1 second pendulum, the positioning of the Great Pyramid itself, and as people have noticed how so many sites such as Easter Island, Angkor Wat, Petra, so many other, and the Great Pyramid are on this 30-degree tilt of the Earth, which in itself brings us to this 30 degrees of the pendulum and the cube. It just, geometry, time, ancient sites, because 144864 is just embedded in all these ancient sites all across the world, all across time, all across cultures, still to this day, places such as the US Capitol building, here in Australia as well, major public buildings, Parliament House here in Canberra, Eiffel Tower, Arc de Triomphe, you name it. They always use these numbers and proportions and this system of measuring time, which emerges from geometry. And it's just all a beautiful symphony of coincidence, and the golden number and the 360-degree compass, 24 hours per day, 60. Yeah, this is actually a wonderful, beautiful system of knowledge. Now let's just assume it is a coincidence. Nonetheless, it's such a beautiful coincidence that I would have to ask, why isn't this method taught in primary school? If you were to learn this geometry, elementary school in America, if you were to learn this geometry, you were to learn just a small grouping of numbers which emerges from this, you would have already gone a long way to understanding the size of each sun, earth, moon, because of course these are all numbers connected to the size of the earth, sun and the moon. It's also numbers connected to time. It's numbers connected to the 360 degrees and the geometry of the beehive, etc. The golden number connected to sunflowers, hurricanes, spiral galaxies, you name it. Even in terms of history, just, you know, whether it's the Great Pyramid and all these ancient monuments built on this axis, they all connect. And when ask yourself, if you've gone through high school, how many people who've gone through high school know the size of the earth in relation to the moon, or the size of the moon in relation to the earth, why the eclipse happens, why the full moon happens? It's all embedded, it's all presented, it's all preserved in this ancient system of geometry, arithmetic, music and astronomy, and it's just friggin' wonderful. And again, why is this considered not considered? Actually, the question is, why is this not considered? Some people would, especially who've been indoctrinated to materialist thinking, don't like this because it suggests something that's unsuggestible. I don't think that really matters at all. This method of teaching, I think, is what is the important tool, is the important reference to it. And again, it is so, you consider the new maths and this new way of teaching, it was pretty poor when I was in school, and it's only gotten worse. And anyway, here's some geometry, here's some numbers, here's some time. It's musical, it's astronomical, it's all connected. And don't hate the G, mate. Love the G. This geometry predates any modern organisation as you know it. If